Hey, good evening. I would like to fix one of the solutions that I posted in video a few days ago. Is the alpha particle colliding with the proton. I did two interpretations that were not correct. The first one I read, and I thought there was two alpha particles colliding with one another, and it's not. It's one alpha particle and a proton. And thinking as being two alpha particles, I thought they would eventually stop and reverse direction based on the fact their speeds were the same. So this is not true. If you have a proton in there, um, and in fact Travis called attention to that point, the alpha particle wouldn't stop. So then he mentioned he would like to solve the problem using conservation of energy and conservation of momentum, which certainly he would figure a nice way to solve. And then I thought that also could be resolved if we think we position ourselves in in the rest frame, or not in the rest frame, yeah, in the rest frame of the center of mass. So um, and so then the problem might be able to be resolved. So let's see if we think about if we think about a alpha particle that has four mass of a proton and has a speed that is given by some fraction of the speed of light, and we have a proton that has a mass m and has a speed that is the same, except they are moving in opposite direction, right? So the center of mass is going to be somewhere here. So the center of mass has a velocity that is given by 4 times the mass of the first particle times its speed, right? Plus the mass of the second particle times its velocity. But the velocity here is negative, right? Negative BC, negative BC, and divided by the sum of masses, 5m. So the velocity of center of mass is therefore 3m BC over 5. Okay. Now, if we are here on the center of mass with the sombrero right there. So if we are sitting over there, what we see is the alpha particle moving towards us with a velocity that is positive, right? It's still going towards the right-hand side. The right-hand side is positive. The velocity is going to be given by BC minus the velocity of the center of mass as seen by somebody outside. Oh no, it's 5m. So I don't have m here. So and which is equal to 2/5 of BC. By the same token, the proton, this is alpha particle. So the proton has a speed, a speed as seen by the person in the center of mass, or has a velocity by seen by somebody in the center of mass that is equal to negative BC plus 3/5 of BC, right? It's negative. That's how you see, right? Because you are moving towards its direction, so you sum up its speed. And so you have a velocity I seen by the center of mass, which is 8/5, negative 8/5 of BC. Okay. So now we can, in the center of mass, when they are getting the closest point, that is true, they stop, right? In respect to the center of mass, they both stop and they reverse direction, essentially, right? Because when they get to the center of mass, this alpha particle will move with the smallest, with a speed less than the center of mass. So you see the alpha particle going away from you. And you see now the little proton moving away from you because now it has a biggest speed and a positive velocity. So it goes to the right. So you see both of them going away. And the closest approach is when the both of them stop. Okay. So if that is true, at this closest encounter, the energy of the system is given by K, the charge of the proton, the charge of the alpha particle, divided by x, the closest distance of it. And in other words, this is the potential, right? Is the potential either seen by the alpha particle or proton, so it doesn't matter, as they are far apart and they get closer to that position. So imagine one of them generated the potential. What's the work done by the other particle to go all the way to the point they are closest, or you go the other way, is equal to the same. And this is equal to the change in kinetic energy. In fact, this is a negative. There's a negative number there. And that is equal to the change in kinetic energy. The final is zero. The initial is a positive number. But the kinetic energy, the initial, is equal to half mass of the alpha particle, which is 4 times the mass of a proton, times the velocity or square of the alpha particle, which is this number here. So it's going to be 4/25 of b squared c squared plus half mass of proton, and this speed here squared. So it's going to be 64/25, and then you add those two. So once you done that, then you can calculate the x. So this is a way of getting by using the center of mass as an argument.